Happy New Year, Dragons. This lesson is over sequence notation and how to fill in a table or patterns given a series of sequence equations. So today we really just have two options, and they're very basic options that will take you back to elementary school. And the options are that we're going to either add or we're going to multiply. Pretty simple. We're either going to add or we're going to multiply. So let's take a look first at adding and arithmetic sequences. So as we take a look right here, I have some notes. When you're adding in a pattern to go from one to the next, it's called an arithmetic sequence. An arithmetic sequence. We're going to add the same number to go from output to output. That is, the dependent variable to the next dependent variable in the table. Or you could say that we're going from y to y. Now, we have this funny looking thing called recursive form. Okay? And we have subscripts. This is a sub 1 is equal to 7. And the other equation is a sub n equals a sub n minus 1 plus 3. Now let's clarify some of these letters over here. N tells us the position within the sequence. Okay, so if n is 1, like it is right here, that tells us the first number in the sequence. And so in order to clarify which of these equations tells us what to do, we're going to say one of them is going to be what we're going to call our start equation. And usually we start with 1. That's a dead giveaway. So this first equation with n equals 1 is going to be where we're going to start our table. And the other one is going to tell us how to move. So it boils down in all these problems to where do you start and how do you move? Well, we already know that in an arithmetic sequence, we're going to add. Now this might be subtraction, but you know that adding a negative is the same as subtraction. So you need to know that family of addition and subtraction in case they put like a minus 3 here. It's still going to work the same way. All right, so let's fill in this table. Let's try to figure out the pattern from these two equations. All right, and I think that this little graphic organizer will let you know, will help you out here. Okay, so that's a start. We're going to take the starting one and we're going to go right here because at the very top of our table, that's where we're going to start. So if we follow these lines right here, we look right here. The first position is going to be a 7. That's really all we can even see out of this first equation. So the first position is going to give me a 7. Okay? Now, we want a pattern. If we want a pattern, what we're going to do is, if this is the first number, I got to ask myself, well, what's the second number? And what's the third number? And so on. What's the fourth number? What's the fifth number? Okay, well, let's come back over here and say, all right, let's look at my other equation. Now, these subscripts with variables right here aren't going to tell us what to do. In other words, I'm not going to subtract 1 because that's a subscript. Okay, really, the only meat and potatoes we have in this is this guy right here. We know that we have to add, and the only thing that is clearly telling us to add is this right here, plus 3. That tells us how we're going to move. So what we're going to do is we're going to come down here, and I want you to actually fill these out. I want you to come back and say, from each output, to get the next one, we're going to add 3. So I'm just going to go ahead and fill that out. And if we write it a couple of times, that's going to burn it in our brain that that's what we're doing. This is how we're moving along the pattern. All right, so now we're just going to follow the ladder, so to speak. And think of this as a ladder. I start at 7, I add 3, that gives me a second number of 10, because 7 plus 3 is 10. Follow the ladder. 10 plus 3 is 13. Keep going. We're going to do the same thing over and over. 13 plus 3 is 16, and we'll do the same thing over here. And guess what we've done? We've established our pattern. And remember, all the ends, what do those represent? What do these numbers represent? That's right, they represent the position in the pattern. Okay, so my first number is a 7. My second number is a 10, and so on. Third number is 13, fourth number is 16, and fifth number is 19. And so there we have our arithmetic sequence. We're adding 3 each time to get to the next term. All right, so that's the arithmetic sequence. Remember, our only 2 options today are either adding or multiplying. So now let's look at multiplying. Multiplying is called a geometric sequence. So instead of adding to go from an output to an output like we did in an arithmetic sequence, we're going to multiply by the same number to go from output to output. Okay? And so we're going to do that same old start and move thing. This is, again, recursive formula. Remember, we got these little subscripts going on over here. Okay? So if we take a look at that, where do we start? We usually start at the first position. So this guy right here is simply going to tell me where am I going to start my table. I'm going to start it at the first one is going to be a 6. Okay? And really, that's all this first one is good for. Okay? Now, as we take a look at the second one, if you notice right here, we don't see a plus sign like we did over. Remember over here we had a plus 3. I don't see that over here. I don't see a minus or anything like that. I don't see addition or subtraction. What I do see right here is I see this 4 squished next to the A, and if you remember, 4 squished next to an A really is 4 times A. So if I look right here, this guy right here, and knowing that it's multiplication, that's how I'm going to move. I'm going to move each time times 4. So I'm going to come over here and I'm going to fill down each one of these because that's going to remind me that I am going to multiply by 4 each time. Multiply by 4. Don't use an x. Remember, x is a variable. All right, and we don't want to be confused. Use the multiplication dot to say that we're going to multiply by 4. And so now, if we know that the first number is 6, the second number is 6 times 4, which is 24. The third number in my sequence is 24 times 4, which is going to be 96. And you can use your calculator to help you out with this multiplication if you need to. My fourth number in my geometric sequence is 96 times 4, which is 384. Check me out if you don't believe me. And finally, my fifth number is going to be 384 times 4, which is 1536. So now I can take my table and say, okay, the first number is a 6, the second number is 24, my third number is 96, my fourth number is 384, and my fifth number is 1536. Now you don't have to put these little numbers up here at the top, this 1, 2, 3, 4, but I want you to realize that they are part of an input-output algorithm when it comes to sequences. Okay? So, again, the process, we got to take a look at our recursive formulas. We got to decide, hey, am I going to be adding in this pattern or am I going to be multiplying in this pattern? And once we do that, we go to our start and move process. Fill in our table, and shazam, we have our sequences. Okay? Now, because this is so much fun, these people have decided, you know what, recursive formula is going to be great, but let's give them another formula. And so I'm going to do that right here. So I'm going to take the same problems. These are the very same problems that we had previously on the previous page, right? So if I take that, notice that on the other side of your paper, it's the same problem, okay? But now, we're going to write it in function notation. All right, let's see if there's anything really major here. All right. Well, do I have a start equation? Well, I know that this guy is my start equation. I start at 1, 7. If I look over here at function notation, you notice they've taken away our subscripts, and they've given us the little italicized F for function notation. If I would take a look at this, can I still see a starting position? Yes, I can. My first position is going to give me 7, just like it is up here using subscripts. So, all right, if you want to give me function notation, I can still get the ordered pair 1, 7 as my starting position. Okay? The second equation in recursive form told me how to move. Well, this has told me to add 3. That's what this told me. Add 3 each time. Is there something down here that tells me the same thing? Yeah. Okay. If I kind of look at the very tail end right here, I see a +3 as well, which is also going to tell me to add 3 each time. So I want you to be able to take a look at these two forms, recursive form and function form. And notice that it really does tell you the same thing. It tells you where to start, and then it tells you how to move. All right. Over here, same thing. This was arithmetic sequence because we're adding. This was our multiplication. Notice 1, 6 is my starting point in my table. Guess what? I can get that information from this guy as well in function notation. I noticed that I was multiplying by 4 over here. That's how I move. I'm going to multiply by 4 each time. Do I see that down here? Yeah, my function is multiplied by this 4 right there. So it tells me the same stuff. So we need to be able to say, you know what? Hey guys, y'all throw any type of form you want at me, either recursive or function notation. I'm going to be able to interpret where I'm starting my table and how I'm moving. Sometimes I'll add, sometimes I'll multiply. Sometimes it'll be arithmetic sequence, sometimes it'll be geometric. All right? So, got a couple of practice problems here that I'm going to ask you to, or Edpuzzle will stop you and ask you to work on your own. So I want you to do that, and then I will work the problem for you. So here's the first one that I want you to do. I want you to determine whether you have an arithmetic or geometric sequence. So you can either put an A or a G from the given equations. Fill in the table, like I did on my examples. I want you to tell me what you did each time. Yeah, I know these will be the same, but I want you to tell me each time. And then I want you to fill in your table and give me the sequence. All right. So this one right here gives me a starting position of 1. My first number is 40. I take a look at my second one, ask myself, am I multiplying or am I adding? What's going on here? Don't see any adding. I'm not looking at the subscripts, right? I'm looking at what's happening to the A, and I notice right here that that is multiplication. Multiplication. So this is going to be a geometric sequence. All right, so I'm going to multiply, but my multiplication dot, I'm going to multiply by 0.5. I'm going to multiply by 0.5. Multiply by 0.5. If you want to do one half is 0.5. It doesn't matter, but that probably just threw some people off, so I'm gonna take that off. But if you're just taking half. That's what you do when you multiply by 0.5. All right. So my second number is going to be half of 40, which is 20. My third number is going to be half of 20, which is 10. Fourth number, half of 10 is 5. And finally, think of money. What's half of $5? That's right, it's $2.50, 2.5. And there we go. We got our geometric sequence of 40, and then 20, and then 10, and then 5, and then 2.5. All right, one more that I want you to check on Edpuzzle. Here's your second one. Please work this one, answer the Edpuzzle questions, and then the video will be, I'll show you how to do it, and then the video will be done. All right. we take a look. This is in function notation. I take a look. Where am I starting? Where am I starting? Looks like my first position is at 11. Okay. Now I need to figure out how I move this function notation. If I take a look right here, I'm not looking at the n minus 1s. I look right there. Oh, I'm going to subtract 3. Now remember, subtracting 3 is the same thing as adding a negative 3. Subtracting 3 is the same thing as adding a negative 3. So this is an arithmetic sequence. All right? So subtract 3, subtract 3, subtract 3, subtract 3. Again, if you want to say adding a negative, it's the same thing. All right, so here we go. Let's follow the ladder down. The second number is going to be 11 minus 3, which is 8. The third number is going to be 8 minus 3, which is 5. The fourth number is going to be 5 minus 3, which is 2. And the fifth number is going to be 2 minus 3, which is a negative 1. Take these guys right here. These are the positions in your sequence. So my sequence is 11, 8, 5, 2, negative 1.